So today what we're going to talk about are reaction types. There are 6 reaction types, so the best way to take notes on these is take a sheet of paper. Up at the top, we're going to put reaction types, and then divide that paper in half. I believe that's hot dog style. And then we'll divide it into thirds the other way. And so this way you have 6 reaction types. We're going to put 1 in each square. All right? You could do this. I'm doing this horizontally because of space. You could do this vertically if you so chose. What I'm going to do now is I'm going to zoom in here, and we're going to put each of the reaction types in their own square. So the first reaction type is synthesis. I feel like that ink was supposed to get a little bit thinner there. Oh, and it did not. Why not? Please go. There we go. Synthesis. Okay, that doesn't look horrible at all. There we go. Synthesis, which is a word you're possibly familiar with, right? You may have had to synthesize things before. That's where we are going to make something new. And a synthesis reaction in chemistry tends to have the general format of where we take 2 things, slap them together, and make one compound out of those 2 things. Those 2 things could be elements, they could be compounds themselves, but in the end we wind up with one big conglomerate, right? One big lump of all that stuck together. So the hallmark of a synthesis reaction is that it has more reactants than products. So it is possible that you could have 3 reactants and 2 products, right? That would still be a synthesis reaction. In direct opposition to that is the next type of reaction, which is decomposition. And decomposition is probably a word you're familiar with, right? Dead bodies decompose, and the way they decompose is they break apart into their constituents. And that's what we see with the decomposition. Its general format is you start with a compound, maybe a small compound, maybe a large compound, but it breaks up into smaller pieces. So we have our compound AB breaks apart into its constituent elements, A and B, right? A plus B. So in this way, we have more products than reactants. And that is decomposition for you. Next up is this block right here. I'm glad I made it extra wide because this one is single replacement. Single replacement reactions are ones where we have like an element all by itself, like element A here, and it is reacting with some compound, BC, and what we're going to see happen is A is going to come in and replace B in that compound. So we're going to be left with compound AC, and the element B got kicked out to be all by itself. So in single replacement reactions, you can always tell what they are because you have a single element on each side. You're going to notice here that when B got kicked out, it didn't go into another compound. It's standing out all by itself. By the way, if you're ever looking these up, you may find some people call this one single displacement or just a displacement reaction. I don't like that. I don't like that at all. I always call them single replacement. And there's a good reason for that coming up later. If you have single replacement, you can also have double replacement. A double replacement reaction is where you have something like AB plus CD. What we can do there is we can take the A and the C, those first 2 elements, and we can have them swap places, doubly replacing one another, leaving us with compound CB and compound AD. So what's happened here is we have 2 compounds on each side. And usually, all those compounds are ionic. This happens most often with ionic compounds. 99 times out of 100, you're going to see this happen with ionic compounds. So that's a double replacement reaction. Next up is my personal favorite. The whole reason I got into chemistry is because I'm a pyromaniac. I mean, I admit it. I love fire. And in chemistry, we are all about fire. Except we call it combustion. A combustion reaction. If you remember from your early days, you may have heard that fire requires three things. It requires fuel, it requires an ignition source, and most importantly, it requires air. Except it's not everything in air it needs, it's oxygen. So combustion kind of comes in two flavors. You could have a single element getting burned in air, and that produces a compound that is a combination of that element and oxygen. Or you could have a compound being burned in oxygen. What usually happens there is A and B get separated and then paired together with oxygen. Combustion must have O2 as a reactant. And notice it's O2 all by itself. That can't be an O2 as part of a compound. It's not the way it works. All right? We're going to show a couple of these here probably in the next video, unfortunately. All right, last but not least, we have redox. A redox reaction is everything else. If it's not one of the other five, it's a redox reaction. And I'm going to be honest with you, redox reactions are super duper complicated. And if you go take a college level chemistry, you'll spend like 4 weeks on redox because they also form a lot of very important reactions in our world. But for this purpose, we're just going to look, and anything that doesn't fit those other five, it's probably a redox reaction. All right, and that's the reaction types.